In this video, we pay attention to important result in series. We have the series denoted by S and index n, which is the sum from 0 to n of r to the power of m. The first result is to show that we can compute this truncated series Sn. We can find an explicit formula for the truncated series in the first bullet, and in the second bullet we will show that when we have an infinite series, we can explicitly calculate it by this formula, where r should be strictly less than 1. Let's derive the first result. So Sn equals the sum from 0 to n r to the power of m. We can expand this r to the power of 0 plus r to the power of 1 plus r to the power of n. So we can write Sn equals 1 plus r squared plus absolute value r to the power of n. Now multiply that by absolute value of r times Sn. So this multiplies the right hand side, r plus r squared plus r cubed in absolute value plus rn plus 1. Here we can do a trick at the right hand side. So we write 1 plus r squared plus r cubed plus r to the power of n plus rn plus 1 minus 1. So this is the absolute value of r times Sn equals, this bit here is the Sn, plus r to the power of n plus 1, take away 1. I take this to the left hand side. I take common factor the Sn. And then I solve for Sn. So the Sn is the absolute value of r to the power of n plus 1 take away 1 in the numerator, and in the denominator we have the absolute value of r take away 1. Now for the second result, we take the limit of Sn as n grows to infinity. So this is the sum from 0 to infinity, and here I have r to the power of m. So I take the limit as n grows to infinity of r to the power of n plus 1 take away 1 divided by the absolute value of r minus 1. This should be the limit as n grows to infinity of r to the power of n times r minus 1 over the limit as n grows to infinity r minus 1. Now if r, the absolute value, is strictly less than 1, this bit here goes to 0. So this term goes to 0, and I end up minus 1 in the numerator over absolute value of r take away 1. So I can write the denominator as minus absolute value of r minus 1. So this is 1. So this is minus and this is a plus. So it's 1 over 1 minus the absolute value of r. And of course r should be strictly less than 1. So the infinite series is given by this relationship here, provided that r is strictly less than 1, so the values are within the unit disk This is the radius of the, let's say, unit circle. The radius of the circle is 1, so the value should be within the circle, so the r should be strictly less than 1. These are two important results in analysis. So this is the first one, and the second one for the infinite series is this one. Two important formulas, and we have showed how to derive these formulas explicitly.